Okay, hello guys. So welcome back to another video of chapter 2, pressure. So for today's lesson, we are going to look into 2.2, atmospheric pressure. So what is, I had talked to you about pressure in liquid. So today we are going to look into atmospheric pressure. I believe in the previous video about problem solving involving pressure in liquid, we mentioned about atmospheric pressure. So today in this lesson, we are going to look into deeply what is actually atmospheric pressure. Now let's move on. So if you look at this diagram, the diagram shows a glass sheet lifted using a large rubber sucker. This is a rubber sucker. So how is the atmospheric pressure applied in the use of this rubber sucker? Okay, now I need you to ponder this question and then I need you to give me answers and feedback in the class. Okay, in the class. So what is atmospheric pressure? So atmospheric pressure is the pressure due to the weight of the layer of air acting on the surface of the earth. I repeat it again. The pressure due to the weight of the layer of air acting on the surface of the earth. Now, I believe I mentioned this one in class related to the gravitational pull, right? So we know that air made up of a lot of molecules. We have in our air, we have carbon dioxide, we have oxygen, we have nitrogen gas, we have a lot of things, okay? A lot of types of gases in our air. So due to the gravitational pull, okay, so that's why the gravitational pull will pull all the molecules towards the earth, am I right? So that's why on the surface of the earth, okay, now all the layer of air got weight. Why? Because all the molecules have mass. All the molecules of air got mass. So that's why the pressure, okay, the pressure that being experienced, okay, around us is actually due to the weight of the layer of the air acting on the surface of the earth. That's why we will feel atmospheric pressure there. Okay, so I hope that you understand on what I'm saying. Let's say you don't understand, I'm going to expand further. You ask me in class, I'm going to expand further. Okay, now let's move on. So this is what I mentioned just now. If you look at this diagram, this small diagram, the earth is actually surrounded by a thick layer of air consisting of various types of gases. I mentioned just now, nitrogen gas, carbon dioxide, oxygen, and so on and so forth. Okay, now this layer of air has weight and exerts a pressure on the surface of the earth as well as all objects on it. Okay, therefore all objects on the surface of the earth experience atmospheric pressure. Now I'm sitting here at my place and you sitting here there at your place also, you will feel the atmospheric pressure. Okay, all right, now so here it is very important that for you to understand the value of the atmospheric pressure. Okay, now how to measure the atmospheric pressure? We can measure it by using mercury barometer. Mercury barometer. Now, this is how a mercury barometer looks like, and how does a mercury barometer being formed? Okay, how we build a mercury barometer. Now, mercury barometer consists of 1 meter long glass tube containing mercury. It's mercury inside. So initially we put a lid on here, and then this is the glass tube, and inside there we have mercury. So I just tunggang terbalikkan dia. So initially the glass tube filled with mercury is covered with a lid, and then after that the glass tube is inverted. Okay, you inverted it, and then you and the cover and is immersed into the ball of a mercury. So this one is also mercury. Then only we remove the lid. Okay, so when the lid is removed, the mercury column in the glass tube will fall until a certain height and remain at that height. So means that it will fall, right? So until this level, it will no longer fall down. Okay, it will no longer fall out from the lid, from the glass tube. So what happened? So we know that this height is actually equals to the atmospheric pressure. That's why my atmospheric pressure is equals to 760 millimeter mercury or 76 centimeter mercury. If you look at the old reference book or some of the reference book, they will write 76 centimeter mercury, Hg. Okay, so you have to understand that unit is not a problem because that's mathematics. You learn maths when you were in primary school, I believe, for millimeter, centimeter, meter. You learned that one in primary school. So I hope that you understand why 760 millimeter mercury is equal to 76 centimeter mercury. If you don't understand, I'm going to, okay, so I move on. All right, now, so when we look at this one, the atmospheric pressure acting on the surface of the mercury in the bowl supports the mercury column. So it means that this atmospheric pressure supports it. The height of the mercury column depends on the magnitude of the atmospheric pressure. And then the value of the atmospheric pressure is stated in terms of height of the mercury column. That's why our value for the atmospheric pressure, we will use millimeter mercury or centimeter mercury. Why? Because we measured it by using mercury. Okay, if the height of the mercury column H is equal to 760 millimeter, then the atmospheric pressure P ATM is equal to 760 millimeter mercury. So in this case, we build out our barometer by using mercury. That's why it's millimeter mercury. Now you have to understand that we will be doing some conversion from millimeter mercury into millimeter air, millimeter water. So you have to understand that millimeter water, millimeter mercury, they are two different things. Why? It depends on their density. My mercury have 1000. Okay, my mercury just now, I have my, my mercury has its own density, and then water also has its own density. So that's why the readings on a mercury barometer is 760 millimeter mercury, but on water, it's different. Okay, we're going to look into it later. Now, still, we are going to use the formula P is equal to H rho G to determine the atmospheric pressure. Now, please remember, because this is in millimeter mercury, we know that atmospheric pressure, pressure normally we want it in Pascal. I repeat again, we want pressure in Pascal. So that's why, how do I change this millimeter mercury into Pascal? You know, right, the SI unit for pressure is Pascal. So you have to know how to convert this 760 millimeter mercury into Pascal. Like I said, when you use, you are going to find Pascal, you have to convert your millimeter into meter, because meter is SI unit for length. So in here, my pressure of atmosphere is 760 millimeter mercury. Then my H is equal to 760 millimeter. I change it to meter. I hope that you know how to change it to meter. It's equals to 0.76 meter. Then my density of my mercury is 1.36 times 10 to the power 4 kilogram per meter cubic. So this is what I have here. Okay, because my density of mercury is 1.36 times 10 to the power 4. But what is my density of water? 1000. Okay, remember, right? It's 1000. Okay. Then after you have this, okay, I have all the information, the density, the height, and then you just put it into the P is equal to H rho G. By using P is equal to H rho G, I know 0.76 times 1.36 times 10 to the power 4 multiplied with 9.81, I get 101,396.16 Pascal. Normally, we will round it out into 101396 Pascal. So this is the value that normally you will see when you answer the question. So this is the value for atmospheric pressure in Pascal. Please remember, this is the atmospheric pressure in Pascal. Okay, so the value of atmospheric pressure can change with weather. I repeat, the value of atmospheric pressure can change with weather. In addition, the thin air at higher altitudes causes the atmospheric pressure to be lower. Okay, now, like in the previous slide I explained about the gravitational pull down all the gases towards the surface of the earth, right? So let's say if you have that kind of, you have this experience to go go mountain climbing, you will find that the air on the higher altitude is actually thinner. Why? Because most of the air is actually on the surface of the earth. Okay, so the higher you go, the higher the altitude you go, the thinner the air. So due to the thinner of the air, that's why the atmospheric pressure will become lesser, will become lower. Same. So when the change of weather, when it is going to rain, normally the changes of the atmospheric pressure also, normally how we predict raining, some people, they can predict raining due to the atmospheric pressure. So that's the amazing thing. So if let's say you like about weather, you like about atmospheric pressure, then you are going to be able to predict, is it going to rain or not? Okay, so this is really, really interesting. All right, now I move on. So another one. Just now we talked about a mercury barometer. Now, mercury barometer is not very suitable to be used to measure atmospheric pressure outside. Means that if let's say you want to just try it in a lab, okay, if let's say our lab have mercury, then you want to try it, then no problem. Then we do it as experiments in class. But I want to say that we don't have mercury in our lab. okay, because mercury is considered very dangerous materials like you learn in chemistry, so we don't have one. Okay, I'm going to explain further about mercury. There's some cases that involve mercury, okay, involve mercury in the lab, so I'm going to explain in class, so I'm not going to talk about that one now. Now, another one that we have is Fortin barometer. Now, Fortin barometer is also known as mercury barometer. Just that the good thing about Fortin barometer is it's actually you have enclosed it everything inside, so it will not fall off. Just that still it's not safe for you to bring it out because it's too big. You want to bring it out to go hiking, hiking, mountain climbing with this Fortin barometer, it's very impossible. It's impossible. Okay, so it is used to measure atmospheric pressure at a high degree, in accuracy. It has a height of almost 1 meter and then usually used to measure atmospheric pressure at meteorological center. So if you have chances to go to the meteorological centers, you will see this Fortin barometer there. Normally we will use until 1 meter height lah. So it's easier. When you have 1 meter height, then it's easier for you to calculate 0.76 millimeter mercury. Now, if let's say you want to station it at a one position, you're not bringing it here and there. So mercury barometer or Fortin barometer is actually a good measuring instrument. Okay, it's a very good measuring instrument. But another one, if let's say you want to go hiking, mountain climbing, it's better for you to bring Aneroid barometer. Now, Aneroid barometer is actually mechanically, functions mechanically. Okay, why do I say so? Compared to Fortin barometer, you cannot bring this one because in the Fortin barometer, you have mercury inside. So that's why it's more accurate compared to this one, okay, compared to the Aneroid barometer. But I want to say this, mercury barometer is also accurate. How does it work? Now, this is very interesting and this is very amazing. Now, for those students who likes to disassemble things, I think this is a very good idea for you to try to build this thing inside. Okay, this is very interesting. Let's say you understand the parts inside, you will know how does it function. Okay, now first thing is I have this vacuum chamber. This vacuum chamber is partial vacuum metal box. Can change its size when there are changes in atmospheric pressure. Means that this vacuum chamber, due to the change of the atmospheric pressure, let's say my atmospheric pressure is high, then it is going to compress the metal chamber, the vacuum chamber. Okay, and then when the atmospheric pressure is low, then it will be released and then it will expand a bit. So what happened? You see this lever. Okay, you see the lever, right? This lever is actually connected to this spindle. So when it is expanding, it will expanding. How to say? When the atmospheric pressure is high, then it will compress it so that lever will move to the left or to the right. So when it moves to the left or to the right, then the spindle will also move. So when the spindle moves, then the pointer will be moving. So that's how they measure the atmospheric pressure. Okay, so that's what we have here. Okay, so the small change in the volume of the box is amplified by a mechanical system to move the pointer of barometer, like how I explained just now what happened inside. Okay, that small changes will cause this lever, this spindle to move. So that movement will cause the changes of the pointer. So that's how they detect the atmospheric pressure and measure the atmospheric pressure. Okay, it is suitable to be used in homes, okay, ships and aeroplanes to obtain a quick reading of the atmospheric pressure. Okay, compared to the mercury barometer, if let's say you want to bring that mercury Fortin barometer and then you build it in the airplane, it's impossible because mercury itself is very, very heavy. You see the density is high, that's why it is heavy. Okay, now I move on. So here. Now, compare between Fortin barometer and Aneroid barometer. You have to understand this. You have to understand the characteristics of both the comparison between Fortin barometer and Aneroid barometer. This one will help you in answer question for section C or section B in essay part, especially when you are going to decide what type of the barometer is more suitable for that to measure the atmospheric pressure at what situation. For example, meteorological centers for sure Fortin barometer is more suitable, right? So you must be able to explain. Give your justification. Why do you think Fortin barometer is more suitable? If let's say you are going to measure the atmospheric pressure on a plane, then are you going to use Fortin barometer or are you going to use Aneroid barometer? So you must be able to give your justification correctly. Okay, now let's go on. So for Fortin barometer, the value of atmospheric pressure is determined by the changes in the height of the mercurium column. So, but for Aneroid barometer, the value of the atmospheric pressure is determined by the changes in the volume of partial vacuum metal box. Okay, then for Fortin barometer, it is larger size and not portable, but Aneroid barometer is smaller in size and portable. Now, Fortin barometer takes a longer time to give a reading for atmospheric pressure, but Aneroid barometer gives a direct reading for atmospheric pressure. So the accuracy for Fortin barometer is higher because it is up to 0.1 millimeter mercury. But for Aneroid barometer, it has lower accuracy, which is up to only plus minus 1 millimeter mercury. Now, I hope that you understand the concept of accuracy. You learn about accuracy when you were in Form 1. So I'm not going to explain in detail here, but let's say you forgot about the concept of accuracy as in class. I'm going to explain further. Okay, for this video, I'm not going to explain that one. Okay, now let's see. The effects of atmospheric pressure at a high altitude and the effects of the pressure in the extreme depth under the surface of the sea. So what happens if, let's say, you are at a place with high altitude, or what happens if you are the person who always go diving? So what happens? So all that will cause problems, but you must be able to understand. You must understand what is the effects of that atmospheric pressure when you are at a higher altitude. Then what is the effect of the atmospheric pressure when you are at extreme depth under the surface of the sea, so that you can take precaution steps to keep you safe. So that is very important. Okay, now let's see here. If let's say we are at a high altitude, now where is the high altitude? For example, pilot, air stewardess, they are always flying. So what happened to them if let's say they are always at a high altitude? Now let's see here. When you are at a high altitude, the air is thin. The thin air will cause the atmospheric pressure to become lower. Then the percentage of oxygen in the air will reduce. So that's common sense. Okay, how does it affect on humans' breathing? So you will increase in your rate of breathing, and then you will have a lower absorptions of the oxygens in lungs because the level of oxygens in the air is lower. Then the increase in the metabolic rate. So when you are having a very high breathing rate, okay, so normally your metabolic rate will be high. Like for example, if you go running, okay, run, you will feel tired, right? Then you will be huffing and puffing. So that's your metabolic rate is high. So that's almost the same situation. So, and then on the same time, you will lose appetite, and then you will have dehydration and also inability to think clearly. Why? Because you don't have sufficient oxygen. That's why you cannot think clearly. Okay, so that's what happened to you when you are at a high altitude. So for mountain climbers, what they have to get ready before they go mountain climber, because you know that this thing, when you are at altitude, this thing is going to affect on you. So you have to take precaution steps. So what is the thing that you have to do? First, prepare and train before climbing. Normally they will ask you to go to do more on cardio, okay, cardio exercise, so that you can have your body can adapt to the low percentage of the oxygen. Okay, because when you do cardio, you are actually huffing and puffing, and then you are going to increase in the rate of metabolism and so on and so forth. So when your body adapt to it, then it's easier for you. It's better for you to do mountain climbing. Okay, then prepare equipment such as smartwatch that can measure altitude, body blood pressure, and body temperature. Climb at a slow rate to allow the body to adjust to the changes in pressure. Drink water even when not thirsty to prevent dehydration. For people who go mountain climbing, yes, they will experience dehydration. Okay, next one. If let's say you are in an aircraft, like I mentioned, like I mentioned, air stewardess, pilots. Okay, now they will so what will they do? Okay, in the aircraft, in the airplane, okay, inside the aircraft, normally they close the door, right? So when you close the door, okay, the door is very hard to open. Okay, when you close the door, what happened inside the cabin is they are going to increase the pressure in the cabin, the aircraft cabin, to match the sea level pressure. So that's why sometimes you will feel not that stressed. You will not feel so stressed when you're inside the cabin. Okay, because they are trying to increase the pressure in the aircraft cabin as same as the sea level pressure, but sometimes you will still feel the pop in your ears. Okay, that's very normal. Okay, when you are increased in the altitude, that's why you have to you experience the pop at your ears. Okay, now recycle the air in the cabin so that it is fresh and contains adequate oxygen level. Remind the passengers to drink enough water to prevent dehydration during long distance flights. Now, if let's say for me, I fly from here to Sarawak, it takes about 2 hours and something. Normally, I will not be taking a lot of water. Why? Because it's very inconvenience to go to toilet. That's for me. But if let's say you fly from Malaysia to Australia or other countries where you have a longer flight, longer distance flights, it's better for you to consume enough water. So because you will be experiencing dehydration. Okay. All right. Now, so now when we relate this one, when we relate the things that on the earth, okay, on the earth with high altitude, sometimes we have to take into consideration what happens if let's say we are at the space, we are outside of our earth. Okay, at the outer space, okay, the outer space is the space outside the earth's atmosphere. Okay, it is outside the earth's atmosphere. You don't no longer feel the atmospheric pressure. So the pressure in the outer space is almost zero. And then the spacecraft that carries astronauts needs to be pressurization of the spacecraft cabin to match the atmospheric pressure on the Earth so that the astronauts do not need to wear a pressure suit while in the spacecraft cabin. If let's say we watch movie, related to the space, right? You will find when they come out from the cabin, they're going to put on the pressure suit, right? If let's say they are inside the cabin, they don't put on that because they are trying to increase the pressure inside the cabin almost the same on Earth, but they cannot increase it until like what you have on Earth. Why? Because there's no gravitational pull when you're at a space Earth. Earth gravitational pull when you're at certain level outside of the Earth. Okay, so that's the thing. The installation of air oxygen generator to supply oxygen to the astronauts. You have to remember, if let's say you are an astronaut, to stay outside of the space of the outer space for 1 year, how much oxygen you need to supply to the astronauts. So they must have enough and sufficient oxygen. Okay, so they cannot simply just say give out oxygen as much as like where you are on the Earth now. No, they cannot. So that's why for astronauts, they have to have training before they go there, before they go to the outer space. If they don't do training, they will faint it. They will sure faint it one, okay, halfway before they reach the outer space. Okay, because insufficiency of the oxygen. And then there are some of the astronauts will also experience hallucination due to the lack of oxygen. Then they have problem in thinking, right? They cannot think properly. So that's how they will have hallucination. Okay, so that's what happened to the astronauts. And then a supply of pressure suits to be worn by the astronauts when exiting the spacecraft in order to balance the pressure in the body. So that's why when they comes out from the cabin, that say they want to repair something or they want to walk on the moon, okay, they have to put on the pressure suit so that their body can adapt. They have to because our body actually adapted to the atmospheric pressure on the Earth. So if let's say we want to change ourselves to another Earth, another galaxy, then our body still, okay, we still have to use the pressure suit, okay, so that we can adapt to the surrounding. Okay, so that's some of the info gallery that you have to know. All right, now another one. If let's say you are at an extreme depth under the surface of the water, okay, surface of the sea, like like diver. There were people that go diving. I told you, right, in Korea, the diving career is very famous because they like to go into the sea and then they like to find a lot of things, right? A lot of the food from the sea. That's very interesting fact that we have in Korea. Okay, so let's see here. What happened if let's say you are at the extreme depth under the surface of the sea? So first thing is the water pressure increases with its depth. So the deeper that you go, the water pressure is increasing. The water pressure is higher, getting higher and higher because P is equal to H rho G. Then an increase in depth of 10 meters causes an increase in water pressure by 1 atmosphere. So every 10 meters you go down, your atmospheric pressure plus 1. Okay, your atmosphere, every 10 meter you go deep down. Okay, this one I have to mention the atmospheric pressure. I haven't said about the actual pressure. The actual pressure is 10 meter, right? 10 meter multiplied with the density of the water and multiplied with the gravitational acceleration. But at the same time, you are going to experience the atmospheric pressure. So every 10 meter you go inside, beside the pressure of the liquid, you are going to also experience the increase of 1 atmosphere. Okay, so that's what happens. So the water pressure and atmospheric pressure are experienced. So that's why I said you are going to experience both water pressure and also the atmospheric pressure. Okay, so what happened to you? Let's say you are in an extreme depth of water. So first thing is your body tissues will absorb excess nitrogen gas because you know, right? Our surrounding, we have more nitrogen gas. We have more nitrogen gas. That's why your body tissue will absorb excess nitrogen gas. And then the nitrogen gas will dissolve into the blood. So then at the same time, you will have problem to think clearly, which is you are unable to think clearly. The formation of nitrogen bubbles in the tissues or blood vessels if pressure is reduced too rapidly. That's why if you look at the people who go diving, they are not going to go extreme diving. Okay, first, okay, this is very dangerous. If let's say we have excess nitrogen in our blood, it will cause problem. Okay, now I need you, maybe I need you to do some study, and then maybe you go to internet and try to find what happened if our body have excess nitrogen. Okay, we're going to discuss this in class. All right, now, so how are we going to solve the problem, or how are we going to learn to adapt this? So here, if you are divers, do physical exercises to enable the body to adapt to a high pressure environment before diving. Wear a diving suit to slow down the heat loss from the body. You know, right, the water, the deeper that you go in, the deeper you go into the sea, the water, the temperature of the water is getting colder and colder. It will be getting colder and colder, and then it will go very fast. It will drop very fast. The deeper that you go, the temperature of the water will drop faster and faster. Okay, slowly ascend to sea level so that the nitrogen bubbles do not form in the tissues and blood vessels. Okay, so that's how we have to solve the problem of the nitrogen in the blood. Okay, now how about submarine? Now, submarine is made of steel or titanium with a circular cross section, bulat, okay, cross section to withstand the high pressure of surroundings. Pressure in the cabin of the submarine is controlled to almost the same level as sea level for the comfort of the crew. And then oxygen tanks or electrolytic oxygen generators are provided so that the oxygen supply is adequate. Now, it's almost the same as when you are in the aircraft. So in the aircraft, they are going to increase the pressure, but in the submarine, they are going to reduce the pressure almost to control it, like almost the same as the sea level. Okay, so you will feel more comfortable inside it. Okay, so that's the thing. Now, so this is some of the interesting facts here. So a diver who dives to a depth of 30 meters in search of pearl oysters will experience a pressure 4 times the normal and atmospheric pressure. You see here, now this pearl oysters it's a very famous career in Korea. Yes, if let's say you have a chance, you go and find information about divers. Okay, you will see there are a lot of that kind of careers there. Okay, now it's very famous, and sometimes if let's say you have a chance to watch the Korean drama, also they will introduce you to this kind of career. Okay, now for submarines moving to a depth of 240 meters, experience a very high pressure, which is 25 times the pressure at a sea level. So like I said just now, for every 10 meters, you will experience 1 meter. But don't forget that you are also experiencing the pressure in liquid. Okay, so this is some of the information that you can, they just give you so that you understand further. Now, for career boost, this is very interesting. If let's say you want to become a professional divers can serve in Navy, work as commercial divers, or serve as recreational trainers at the sea. In addition to theoretical knowledge and skills, professional divers need to undergo a series of intensive training in order for the diver's body to adapt to the extreme pressure. Now, People who go diving is actually very, very dangerous. Okay, it will cause problem to their health. Okay, it will cause problem to their health. Now, if let's say you have a chance to see the documentation about divers, right? Maybe YouTube a lot, you can go and try to find. Some people who had been working for diving for long time, when they were old, or they are old, they will experience certain health problem. Okay, they will experience certain health problem. That's why it is very important for them to undergo intensive training. Besides knowing about all the knowledge, okay, knowledge that I share with you, they have to go intensive training to keep themselves healthy. All right, so this is the interesting fact here. All right, so I believe this is what I want to share with you about atmospheric pressure. Then I see you in class. If let's say you don't understand, just ask me in class. Okay, so that's all from me. Thank you, class.